Hello chemists and welcome to Bale's Chemistry. In this episode we're looking at how we can test for halide ions using silver nitrate. This is AQA specification 2.4 halogens. In this lesson we're going to be looking at the initial test, what the equations are for these reactions, how we can use ammonia to confirm the test results, and how we can use this technique to produce a dry sample of a silver halide. Now, Bale's Chemistry is expanding to be more than just a YouTube channel. Check out the questions to support your learning at baleschemistry.co.uk and find me on Instagram at bales_chemistry, or just stick around here and subscribe to the channel. So we're going to focus our attention on the first four halogens. We're going to start by reminding ourselves about turning these halogens into halide ions. They become fluoride, chloride, bromide, and iodide. Now, for these halogens to form halide ions, they are reduced, which means they are going to gain electrons. Halide ions form a variety of common ionic compounds that we see in everyday life, and these dissociate in water to give those halide ions. Now, to test for those halide ions, fluoride, chloride, bromide, and iodide, we're going to react them with silver nitrate. These will form silver halides, silver fluoride, silver chloride, silver bromide, and silver iodide. Three of these form precipitates, and this is the most important bit to take away from this lesson. Silver chloride is a white precipitate, silver bromide is a cream precipitate, and silver iodide is a yellow precipitate. So to complete this test, we'll start by adding nitric acid, which removes any impurities, especially those carbonates, which will also form a white precipitate, which gives a false positive for the chloride test. In the second step, we're going to add our few drops of silver nitrate solution, and then finally, we're going to give them a gentle shake and observe that precipitate. It's really useful to be able to remember the full and the ionic equations for the formation of the silver halides. It's quite a common exam question, and they all follow the same pattern, so once you've learnt one of them, you've essentially learnt them all. Identifying the colour of the precipitates can actually be a little bit tricky. To make this easier, we can add ammonia to the precipitate and observe if a further chemical reaction takes place. If we add dilute ammonia to silver chloride, then the precipitate will dissolve. If we add concentrated ammonia to silver bromide, the precipitate will dissolve, and no concentration of ammonia will dissolve the silver iodide. So we can add two extra steps to our method. So steps 4 and 5, first adding that dilute ammonia, and then secondly, adding that concentrated ammonia. Now, we have to do it in this order because the concentrated ammonia will also dissolve the silver chloride. So we need to test that first with the dilute ammonia. It is sometimes useful to also remember the equations for the reaction with the ammonia. Again, these both follow a similar pattern, so it's just a case of swapping the bromide and the chloride ions around, depending on which one you want to represent. One of my top exam tips then is remembering to always add the nitric acid in your methods. It's really important as it removes any of those impurities which gives us false positives, especially like those carbonates. Now this reaction can show how we can make a white precipitate, which can often look like the white precipitate formed from silver chloride. Now, on baleschemistry.co.uk, there are over 1,000 exam-style questions for you to practice and get ready for your exams, so go and check it out. And lastly today, we're going to look at making a pure sample of a silver halide. It's becoming an increasingly common exam question to ask in exams, preparing a sample of that pure silver halide from a mixture of different halides. So first off, we'll start by removing any impurities with the nitric acid. We'll then add in a few drops of silver nitrate to make our silver halides. Then we're going to use the ammonia to dissolve any unwanted silver halide. So for example, if we were trying to make silver chloride, we might add some concentrated ammonia to dissolve the silver bromide. Then we're going to filter off the silver halide we want to dry. And then we're going to place it somewhere nice and warm so it can dry out and become that pure solid that we want. Now, to finish with those key points, halide ions are identified by the reaction with silver nitrate. Remember to add the nitric acid to remove the impurities. Don't forget your colours, so chloride ions are white precipitates, bromide ions cream precipitate, and iodide ions are a yellow precipitate. And don't forget that you can use different concentrations of ammonia to distinguish between those different halides once you've tested them. Thank you, chemists, for watching this episode of Bale's Chemistry. There's more halogen chemistry up here, and if you haven't already, click down here to subscribe to the channel.